All right, we are live. I will make you host.
Awesome. Thank you, Marie.
Mm-hmm.
Okay. Hi, everyone. Today we're going to talk about um, building an MLOps platform with Redis, Spark, and Featureform. At any point in time, if you have any questions, if you're on LinkedIn or Twitter following in, feel free to ask. I'll make sure to answer them. You can also throw them in our Q&A, and I'll make sure to answer them when I have breaks throughout the content. Our agenda today is we'll start by just we're talking about feature platforms. I like to start with the why before the how do we build it. Let's talk about why we should build it, and when we shouldn't. We'll talk about the components of a feature platform, the different types of feature source, and feature platforms, and then finally I'll give just a very short demo on a specific one running Spark, Featureform, and Redis. So feature is a very overloaded word. I like to start with this whenever I'm doing something like this. Features are inputs to models. If you're Spotify and you're making a music prediction, you might want to know a user's favorite song in the last month, their top genre, etc. Those are all features. They're signals that we feed to the model so they can make a prediction. And so a feature platform is a way to define, manage, and deploy those features. So everything with regards to essentially the data pipelines that feed machine learning models, that's all within the realm of a feature platform. There's 5 reasons you'd want. Oh, the other thing I should add is that feature store and feature platform, there's a difference between them. Um, I'll use them relatively interchangeably. At the end, I will talk about the 3 different types. And I think that'll create a lot more clarity. So there's 5 reasons that people use and build feature platforms: to facilitate deployment, enhance collaboration, organize experimentation, increase reliability, and finally, to preserve compliance. So I'll talk about all 5 of these values. But first, I should talk about how a feature is built today. So today, there's kind of 2 stages of building a feature. There's the first stage, which I'll call the experimentation stage, where you kind of typically are working locally. You are playing with your data, you're trying different things, and you're eventually coming up with a set of features or a single feature to actually try to train a model on. And then there's a phase which is deployment, which is distinct. So a deployed model or a deployed feature is typically going to look a bit different than a feature experimentation. So let's first talk about experimental, like building a feature during the experimentation stage. Most of the time, we'll be working in notebooks, which again, you probably don't put into production directly, which is one key difference. You'll be interacting with your data sets in some way, depending on how your company does it. You'll be building transformations. Unlike in when you learn machine learning, you go to a Coursera class or something, they give you these perfect CSVs, and the features are ready to go. In practice, most of the performance gains that I get building ML models comes from the features themselves. So a lot of time is spent fine-tuning those signals. So I'll work in a notebook, I'll create these data transformations, I'll create a set of features, and then I'll feed those into my model. That's the short of building a feature. And so in the experimentation stage, I'll be working in notebooks much more. There's a lot of experimentation, a lot of throwing things away, a lot of analysis. And a lot of this is kind of done locally. I typically won't deal with like streaming data. I won't deal with performance, latency. I'm just really trying to find and curate that perfect feature. But production things are much different. I suddenly have to start thinking about latency. I have to think about uptime. I have to think about error handling. I might have to think about stream processing. Even with batch processing, I have to think about scheduling. How often do I update my features? There are features that might require data from the user's request, which we call on-demand features, which I'll also have to deal with. So there's a variety of different problems that exist in production that are very distinct from experimentation. In fact, in experimentation, I might be using a framework like Pandas. Production, I might have to have either me or an ML engineer or someone might have to rewrite that into even Java or something to get the streaming feature to work. So there's this gap between getting my features from experimentation to production. A lot of the times, we'll have these perfect features in our notebooks, and getting in production is a huge blocker. Can take a ton of time. It's very error prone as well. There's kind of two ways I typically see this solved. One is that data scientists themselves are writing Airflow and PySpark jobs. This can work. It's just in practice, data scientists aren't always the most. It's not what we're trained for. It's not like our best skill. Like we're very good at taking data and delivering insights from it, building features, building models, dealing with production grade systems, uptime, latency, etc. Can be done, but it's typically not our expertise. On the other side, another really common paradigm I see is when data scientists hand off their notebooks to a data eng team, an ML eng team, someone else to get it in production. The problem there becomes the game of telephone you end up playing. You're kind of writing your code in one language in one form, and then it has to get transpiled to a different language. This is error prone, takes a ton of time, and it creates confusion of ownership. Because if a feature stops working in production or the quality goes down, who owns that? Is it the data eng team? Is it the data scientists? It creates a split decision structure for who owns a feature, which can cause problems. So a feature store or a feature platform makes it possible to write your features in a way where they are simultaneously usable in experimentation and typically with relatively minimal changes are easy enough to get into production. So one value prop of a feature platform is making it easy to take your features from notebooks and experimentation into production. The next piece, which is really important, is enhancing collaboration and organizing experimentation. It's so common for even like myself, like when I would build features a lot of the time, a lot of the documentation we would do is manual. But keeping that documentation up to date, especially when you're iterating a lot, can be really tough. So organizing your own experimentation is typically really manual and oftentimes doesn't get done or doesn't get done at the level of quality that makes it useful. As a side effect for that, it makes it really hard to collaborate. Because right now, like to collaborate, what's really common is sending CSVs over Slack or sending notebooks to people, just emailing a notebook to someone. It's pretty ad hoc. It's kind of like, here's my code or here's data. Like, like good luck. Like go, you can use this if you want. Rather than having a much more efficient collaboration process. If you have a software engineering background, like Git is just a core and the workflows around Git are just core to collaboration. If you have a team of more than 5, even less, but definitely have 5 software engineers, working without Git is almost impossible. It's just so error prone. But the same thing doesn't really exist for features. And so one value prop of a feature platform is to organize experimentation and makes it easier to collaborate. It's just so common to like just not have any feature documentation, to have a feature in production and not know what it is and how it's built. You have pipelines in production, and there's all these different steps. It's not even really clear what those steps are. why those steps exist. If something breaks, how do I fix it? It's also really common. I've had situations where I'll have a training set, like a data set I'm using to train, and it's not really clear how I can regenerate that training set. I think this little meme kind of captures the essence of the problem. It's like I'll have features in production, but to get them there, there's just a graveyard of untitled notebooks, poorly named variables in notebooks, like V6, V4, V3, like tables are just not really descriptive names. Um, Lots of this ad hoc. I ran this script to copy this data to here, or I manually edited this row, or whatever. Or I have like 6 Python files that you have to run in a specific order to clean up your data set. And then obviously like a mix of just ad hoc stuff everywhere. And finally, coming back to that same point, none of this is documented. I've heard all sorts of funny stories of like people going on vacation, coming back, and it's like they have a table called feature table, and they come back, and then all of a sudden there's a feature table V2, and they have no idea who built it. They don't know why it's there. They don't know like how it's different than theirs, and it's just a really just a poor process. So not the final, but the second to last value is increasing reliability. Because once features are actually in production, it's not over. Features in production, they're dealing with new data coming in. That data changes. That data can break. The upstream can break in some way. Your features, their distributions are changing typically. There's drift. And if you're not keeping track of your features and monitoring them after they get to production, what ends up happening a lot of the time is all of a sudden a model breaks, or even worse, it's just been slowly degrading over time until at some point, um, it it's we have to go fix it, and then you have to try debug what's happening, why it happened. You have to start going into all the features, into the feature pipelines that, as you remember, aren't even documented, and to try to figure out what's happened. So monitoring is a core value prop of feature platforms. And then the final one, which I'm not really going to get into here, is preserving compliance. This is dealing with governance. It's dealing with all sorts of different things. So the goal of a feature platform is to do all these things. So the reason you would build a feature platform is to make it easier to get your features in production, to make the process of building features much more collaborative, much more organized, to make production features more reliable, and to make sure throughout this entire process that compliance is preserved. That's why people build feature platforms. Now, what are the components of a feature platform? So I'm going to go into the most basic components, which are these 5. The data source, the transformation, the inference store, and the training store. So every feature starts with a data source. There's typically some raw data that is eventually turned into a feature. Almost always, that raw data is transformed via a series of transformations to turn it into the final feature values. Those features need to be served with low latency into production. So for example, if you need to make a recommendation for a user, you don't want to be building all of the user's features from scratch every single time you need to make a recommendation. Rather, you'd want to pre-process those features and store them in an inference store for low latency retrieval. You also need a training store. A training store maintains the historical values of features. This makes it possible to train your model. So when you train a model, you are essentially replaying time and showing it different data points, different examples of things that happen to train it. So it can make predictions against old feature values. It will make a prediction, and you compare that prediction to the label, which is more or less training. So these are the main components. Now, underneath all of these components is infrastructure, right? Like the raw data doesn't just exist in a vacuum. It's stored somewhere. It could be like Azure Blob Store. It could be in S3. It could be somewhere else. The transformations don't just magically run. They run somewhere. And typically that's going to be like in this example today, like in Spark. The training store as well, like the training data needs to be stored somewhere. And then the inference store, the low latency cache, also has to be backed by infrastructure, something like Redis. There's a lot of other components to a feature platform, which are kind of out of scope for today. From streaming backfill, point in time correctness, governance, monitoring, error handling, alerting, audit logs, GDPR data deletion, search and discovery. So these are just the very, very basics of a feature platform. On top of it, you're going to kind of want to build this whole application layer and framework to handle all these unique problems. And that's kind of why we built Featureform. The idea of Featureform is you use it as a framework, it's a Python framework. You write your code, both SQL or PySpark code, in the Featureform framework. And then it will orchestrate your infrastructure, whether it's Spark and Redis, like in this example, or something else, to behave like a feature store. So more or less, it has this like scaffolding, which is the whole feature platform. And you plug in the infrastructure that you use or you decide to use. And it provides all of this stuff and more. Getting to like what a feature platform is and Featureform's approach to it. We make it possible for a data scientist to declaratively define their uh, excuse me, their transformations. So you as a data scientist are still writing your own transformations. And uh, there's in doing that, all of those transformations, all the features that get declaratively defined, all get stored in one place. It's like a single source of truth. It's collaborative. There's search and discovery, there's versioning, there's lineage, there's sharing. There's monitoring and alerting, like we talked about, which is like a core part of a feature platform, is making sure your features in production are behaving as you'd expect. Governance, and then finally orchestration, so that we actually need to build those training data sets. We need to build those features using the transformations provided. We might need to update them. We might need to deal with streaming jobs. There's a lot of things that come into this. And finally, those features can be used both for inference and for training. Now, let's talk about the infrastructure itself. Like in this example, we're talking about Spark and Redis. I want to talk about Redis for a moment. Redis is a really commonly used feature store online store. So it's like, again, part of a feature platform. You'll often see Redis. It makes it really possible, really easy to do basic retrieval. So if I have a user who needs a recommendation, I'll pull those users' features out of Redis to make a prediction. Redis also supports vector similarity, which is also really relevant for LLM applications or other sorts of applications that might also use a feature platform. So you have these sources, you have the feature platform, and as part of the feature platform, you have the offline feature store and the online feature store. The online feature store being Redis, the offline feature store being maybe a mix of Databricks or something else. And that's used for training and for inference. So with Featureform is going to orchestrate all of this together. It will sit above Databricks and Spark and Redis and all these different components. And it will use the infrastructure to make sure that you get the performance guarantees you'd expect. But you don't have to deal with kind of plugging all these things together, making them all work together in a cohesive way. Like Featureform handles that. It's again that scaffolding to plug into. There are three types of feature stores. So everything I described is our as in Featureform's view on how to think of and build a feature platform. But there are other approaches, and I want to talk about them real quick. One, and the most common approach, is implied by the name. When people hear feature store, they think, a database where features are stored. It's a feature store. This is the approach that certain feature stores take. Like Feast is an open source example, SageMaker, Databricks is feature store. Their approach is to treat features like an artifact, like a table. So you build feature tables and you store those feature tables in a literal feature store. That's their approach. Those features can be served. So there is an online store and an offline store. So they can be served both for production and for training. However, the transformations, the actual logic that's tied to those features are separate. So it doesn't really facilitate deployment. Like you still have to build your own feature pipelines in production. For versioning and collaboration and organizing experimentation. It's not really done because the features is most of what you're iterating on. You're not really like creating 100 feature tables as much as you are just building different transformations, tweaking your transformations to achieve the feature set you'd like. So that's the key difference. And this is the most common type of feature store that you'll see. A lot of the people who use a literal feature store will actually end up building kind of the rest of the feature platform around it. So in a sense, a feature store is almost just like one component of a feature platform. Um, sorry, did I miss one? The other type of feature platform, which I missed a slide for, um, allows you, it has the transformations included as well. And this approach is where the feature platform does the transformations and the storage, but the transformation and storage, that infrastructure underneath it is part of the feature platform. So it doesn't have a plugin architecture. It kind of has, it's like its own type of database. So you wouldn't use Spark and that feature platform. It would just be the feature platform. It would replace Spark in your infrastructure. Our approach, the virtual approach, makes it such that you have your resources. You are essentially defining your features, defining your training sets, and it's orchestrating it on top of your infrastructure. So you're not necessarily replacing your infrastructure, but rather our approach turns your infrastructure into a feature store. You can think of us like an application layer that we sit above your infrastructure layer and provide the application experience of a feature platform above it. And again, like what you're doing is you're defining your logic in the Featureform framework. And then finally, that becomes, it gets kind of orchestrated and translated into actual data transformations and storage underneath. So I'm going to show a demo of just a really short demo of how Featureform looks with Spark and Redis in practice, so you can see what a feature platform looks if you were to build it using these three components. So I believe, one second. Let me make sure I'm sharing this. I'm also going to make sure I pull out a notebook. Obviously, if you have any questions thus far, feel free to throw them out. Otherwise, I will continue. So let me get my Zoom back here. I will share this screen. So let's start with the UI. I think it's a good place to start. So with Featureform, you have this dashboard. In the dashboard, you can see your providers. So for example, I can see my Spark, I can see my S3, I can see my Redis. So Featureform itself gets deployed, it can be deployed on Kubernetes or somewhere else. When it's deployed, you configure your infrastructure. So you kind of register Redis, you register S3, you register Spark with it. In this example, I've already done that. Once you register those components, you can start to register your data sets. So for example, I have this transactions data set. And let's do this one. So you can see that I have a transactions data set, and this is the path for it. And I can preview. I can look at what the data is. Um, as my as the data comes up, you can take a quick look on what this thing is. Now, like I said, it's quite rare for data sets to be uh perfect. Like it's never happened to me in practice where like you have a data set, you don't really do any feature engineering, and you just use it as is. That's never happened to me ever. In fact, most of my time is typically spent with feature engineering. And so those transformations are also defined in Featureform via Python, which I'll show you soon. And you can start to build new data sets off of the original transformations. You can even get more complicated. Like I can grab like this Windows X where you can see my description. You can see a much more complicated transformation. You can preview that data. You can see the training sets that are built off of this data. You can see features and other things that are built off of this data set, which I've built. If I look at like a feature, I can see the feature itself. I can look at stats and monitoring associated with it. Again, like once the feature's in production, you need to actually monitor it and see how it's performing, see how the data is changing over time. And then those are kind of the key components. Obviously, there's training sets as well. You might also want to be able to look at the model. And in the model, you might want to be able to look at training sets that that model is trained on. If this model is in production, you could see the features that's using in production as well. And that's how all the components come together. Now, in practice, you'll be doing a lot of that stuff via Python. So here I have a very simple notebook. In this notebook, I have Featureform, Spark, and Redis set up and configured. The first step is to just retrieve the infrastructure. So notice that like I will have pre-configured. Let me zoom in a little bit, make this a little easier for you all to see. Um, I'll have pre-configured Spark and Redis, like I showed you in the provider screen. I already have Spark and Redis, like Redis Sandbox and Spark Sandbox. So I can retrieve those things using the Featureform framework so that I can build using them. I can start building transformations where I specify, hey, I have a transformation on Databricks. It's a data frame transformation. Here are my inputs. Here's the name of the new data set that gets created. Here's the documentation. The logic, which this logic is actually just exactly as it would have been without Featureform. It's just PySpark. And when I run just this part, it will build a new data set called %balance, which is built using running this transformation on transactions. In Featureform, everything can be converted to and from a data frame. So if I wanted to analyze that data set after, it would be quite trivial to do so using client.dataframe. You can define your features. You can define your labels. This is all happening declaratively, your training set. And once you define these things declaratively and you apply them, then they will exist in Featureform. So Featureform will store the metadata. It will run the transformations for you. It will copy the feature to the online store to Redis in this case, which you can see I'm setting here. It will build a training set for you and store that necessary. And it makes it easy to retrieve those things. So I can call client.training set and retrieve my a data frame of my training data. So I can actually train a model. I can also retrieve my features. So I have these two features. I can retrieve them for this user, and I can include any parameters, request time parameters as well. So when you building a feature platform with Featureform, Spark, and Redis is pretty trivial. If you have Spark and Redis deployed, you have to deploy Featureform and then configure it. You essentially register Spark and Redis with it. Once you do that, you are given a framework to define, manage, and deploy those features so that it makes it easier to get your features in production. Everything you do is versioned. Everything you do is like governance is included if that's relevant to you. All the features in production are monitored. It's easy to share things and discover things because you have a UI that has has search, has tags, has different ways to dig into your own usage of features. And all this comes together to give you a flexible feature platform that may work for your use case. So that's all I have for today. It's a bit definitely a bit of a shorter webinar. If you have any questions, I'd be happy to answer them for you. So you can throw them in the Q&A, and you can throw them also in LinkedIn if you're on LinkedIn or Twitter, which Maria will look at and make sure that I get those questions. Otherwise, Maria, I'm going to give you back host, so we can wrap up, assuming there's no questions.
Sounds good. Yeah, I'm looking out for questions on LinkedIn.
Cool. Well, Mary, why don't you talk about the email you send after and all that sort of stuff?
Sure, absolutely. Thank you guys so much for attending our webinar. After this, I'll send a email follow-up with just links to the recording of this webinar. I'll also send you more information about joining our Slack community. It's a great community if you're using Featureform or you're in the world of MLOps to go and communicate with other people in the network, as well as us. And then I'll also send you links to our docs in case you're using the product and you want to learn more about it. Other than that, have a great rest of your day, everyone.
Thanks, everyone.